Hey, welcome back everybody. It's time for lesson 15 of the Dead Earth game development series, brought to you by Gary Simmons here of the Game Institute. Now, in the previous lessons, we put together some pretty simplistic demos that had our zombie Jill here navigating a series of waypoints using root motion, and in a way that didn't see her walking through any solid geometry. We also saw how to build a simple animator controller and saw how both the controller and the navigation system could be used together. Although these were simple examples, they did lay the foundation for what is about to come, because in this lesson we are going to begin the process of developing the real AI system used by the zombies in the Dead Earth game. Now, this is obviously going to be a great deal more complex than anything that we have created so far, so be prepared for this process to span several videos. But before you get disheartened, just remember how important this system is. We're building a game which, at its core, involves you either attacking or fleeing zombies, so the zombie AI is perhaps the most core system of the game. Once our AI system is complete, we're going to be a fair way along the path to having completed our game. Now, the AI system in Dead Earth is comprised of several parts that work together, and we're going to use our Jill game object in our scene here as the prototype. Once we have Jill set up as a fully functioning zombie and prefabbed, it will be trivial to make additional prefabs using different zombie models. Also bear in mind that Dead Earth is still in development as I record this video, so the AI system is by no means locked down at this point. I may decide to come back later and add more features or change some of the features already implemented. But that's all part of the game development process, and you're going to be with me every step of the way as I make these discoveries and decisions. So while developing this AI system, we're going to continue to use this demonstration level provided by Unity Technologies so that you guys can follow along exactly. But once the system is up and running, I am going to then bring in the Dead Earth Hospital level that my brother Darren has been building over in his Dead Earth level design channel. Now, if you're not subscribed to Darren's channel, you might want to check that out as it shows you how he put together the levels for our Dead Earth game. Of course, pretty much everything I'm going to be teaching in these videos is going to be able to apply to any level, so it doesn't matter if you have the exact level that we have or if you haven't purchased the asset packs that we're using. Okay then, so the AI system used by a zombie in Dead Earth comprises of several parts that must work together. First, Jill is going to need to have several colliders and triggers added to her hierarchy that will provide her with her sensory input, what she can hear and what she can see. We will have to write scripts for those collider/trigger game objects that process the trigger and collision messages and send them to Jill for processing. Of course, providing Jill with a list of things she can see and hear is not a lot of use on its own. Jill will need a series of scripts to act as her brain and make decisions based on that external stimuli. We will write an AI state machine behavior for exactly that task. The triggers and the colliders will provide Jill's state machine with what she can see and hear. Each update based on that stimuli, the state machine will decide whether it's time, for example, to transition from a patrol state into an attack state, or from an idle state to a patrol state. The AI state machine will be the master manager of all the individual state behaviors available to Jill, and will keep track of which state is currently active. It will be responsible with providing that state with all the information it needs to function effectively. The AI state machine will also be responsible for maintaining Jill's characteristics. How much health does she have left? What is her hearing range? How far can she see? How much damage is she inflicting or suffering as a result of a current attack? The final component of the system is the animation state machine, that is, Jill's Mechanim animator controller. Now, while it might not seem initially correct to include the animator controller as a subsection of the AI system, we've already seen that the animator controller will have to be closely coupled with the AI state machine. The animator is providing Jill with her root motion. And furthermore, you're going to see later when we examine animation curves that the animator controller is going to be actually feeding the AI state machine with vital information that the AI state machine requires to function, such as where within the middle of an attack animation that might be currently playing should the zombie's hands inflict damage, and so on. This is a two-way street. The AI state machine will also need to be constantly feeding the animator controller with its parameter values so that the will of the AI state machine can be manifested visually. There is no point having an AI state machine thinking, hey, look at me, I am sprinting at full speed, if it hasn't told the animation state machine, which is still playing a slow walk animation. Especially, as we've seen, the animation state machine is actually providing the root motion and therefore the speed of the character. So let's start by doing a little bit of project cleanup and taking out of our Dead Earth folder some of those temporary scripts that we wrote while learning Unity systems. For example, in the Animator Controllers folder of our Dead Earth folder, we have the Nav Agent Authority and the Root Motion Authority Animator controllers. These were just temporary controllers we created to teach Mechanim, so you can delete them, or you can do what I'm going to do, which is just drag them down into our Navigation Example folder, so that if you need to refer back to them as a reference, they still exist. I want the Animator Controllers folder inside my Dead Earth folder now to only contain the real controllers that are being used by the Dead Earth game. Let's also go down to our Scripts folder. There are lots of scripts in here that we no longer wish to use. The only one we're going to use in the actual game is the AI Waypoint Network script. So let's select the other three and either delete them or do what I'm going to do, drag and drop them into the Navigation Example folder. Also, if we select Jill in the hierarchy, we can see that Jill is still using the Nav Agent Root Motion script. Let's remove that. It's not going to be used by the Dead Earth game. The next thing we want to do is add a capsule collider to Jill that roughly bounds her body and assign that to a custom layer. We're going to use this capsule collider to detect when the zombie's body enters certain triggers throughout our level. One such trigger is a trigger that surrounds the player, which I call the melee trigger. It's like a big capsule collider that is very baggy around the player. When the zombie's body enters this trigger, the zombie is notified that it is now within range of the player to invoke a melee style animation. So in order to do that, we're going to make sure that Jill is selected in the hierarchy, and we're going to choose Add Component. We're then going to type in cap for capsule and choose Capsule Collider from the list. We then wish to roughly size this collider and position it such that it bounds Jill's body. As this collider is not really being used for any form of collision detection, it doesn't need to be an exact fit. Something like this that roughly bounds the body. Don't worry if in the T-pose the arms go outside of its bounds. The settings I set here are offset 0.87 on the y-axis from its center point, using a radius of around about 0.4 and a height of 1.84 meters. It should be set to have a direction along the y-axis, which is the default. We're also going to need to add a rigid body to this game object so that we're notified when it enters certain triggers that are placed throughout the level. So I'm going to choose Add Component, I'm going to type RIG for rig, and then I'm going to choose rigid body. We don't wish our zombie to be influenced by physics in any way, so we wish to choose Is Kinematic. This means we're still going to be notified when this rigid body enters certain triggers, but the physics forces that are at play by the physics system will not be applied to our character, and we will be able to move it normally, or in our case, by using the animation system. Don't worry about the mass, drag, or gravity. These are all ignored when we use the Is Kinematic setting. As this is the game object that contains the capsule collider of our AI entity, I'm going to rename this AI Entity. So I click on Jill in the hierarchy and rename this game object AI Entity. I want this particular game object, or more specifically its collider, to be on its own layer, a layer that is specifically for AI entities. So I'm going to go to the Layer drop-down and choose Add Layer. Then in User Layer 8, my first available free slot, I'm going to name this layer AI Space Entity. I'm then going to select my AI Entity game object and I'm going to assign it to the AI Entity object. It will then ask me if I wish to apply this layer to all of the child game objects. It doesn't matter, they're going to eventually be overridden with their own layers, so for now just say no, I only want it applied to this object, in particular this particular capsule collider. When we set up things such as our melee trigger around the player, for example, we're going to set that to the AI Entity trigger layer. That's going to be a layer that listens out for collisions with any objects on the AI Entity layer. In other words, this zombie's body. In fact, why don't we set up that layer now as well, so it's ready for a little later when we need it. So I'm going to go to the Layer drop-down. I'm going to choose Add Layer again, and in the next available free user slot, I'm going to type in AI Entity Trigger, like so. Then I'm going to select my AI entity object again in the hierarchy view. So just to recap, all of our zombies will have a capsule collider that is assigned to the AI entity layer. Whenever we wish to place triggers throughout our level and want to be notified when a zombie's body enters that trigger, we will assign that trigger to the AI entity trigger layer. In fact, we probably want to adjust the collision matrix in the physics manager so that those two layers are only sensitive to one another and nothing else. We don't want any triggers assigned to the AI entity trigger layer being spammed with lots of notifications about collisions that have happened on layers that it just doesn't care about. This is obviously going to be more efficient as well. So let's go to the edit menu, and from the project settings submenu, choose physics. This will bring up the physics manager inspector, at the bottom of which we can see how the collision matrix is currently set. As you can see, there is a tick box in every square, which basically means at the moment every layer is sensitive to every other layer. We don't want that. So, starting first of all with our AI entity trigger layer on the top here, let's just go down and untick everything to begin with to make things a little bit easier to read. Then we have our AI entity layer. Let's untick all of that too. So now the AI entity and the AI entity trigger layers are sensitive to nothing and would never generate any trigger messages. So in order to fix this, all we have to do is, in the column that is assigned to the AI entity trigger layer, tick the AI entity tick box. Now the AI entity and the AI entity trigger layers are sensitive to one another and will generate collision and trigger messages when objects of each layer collide with one another. So we've now configured the collision system such that we can now place triggers that will be sensitive to the zombie's collider entering them. What we need to do now though is we need to create the sensory trigger that is going to be essentially the eyes and the ears of our zombie. This is going to be a massive sphere collider such that when any objects enter it that the zombie considers a threat, it can store those threats and then its AI state machine can process them and see if any of them are worthy of pursuit. So we're going to need to create a child game object to attach this sphere collider to. So I'm going to click on my AI entity object, Jill, in the hierarchy. I'm going to right click and I'm going to choose create empty. This will create an empty game object as a child of the AI entity game object. I'm going to call this sensor. Then with sensor selected, I'm going to choose add component and I'm going to type in SPH so it brings up sphere collider. I'm going to choose sphere collider and I'm going to set this collider to be a trigger by setting its is trigger tick box like so. I'm then going to open up the radius of this trigger. Actually, I'm going to keep it small for the time being and I'm going to nudge up the trigger to roughly where the head of the character is, and then I'm going to open up the radius to something quite big, like maybe 20 meters. This trigger is essentially describing what the maximum eyesight and hearing range of our zombie can be. When any sound that is an AI aggravator is emitted within this sphere, the zombie will be notified of it and may, if there are no other pressing concerns, pursue its source. Any objects that are considered to be visual aggravators of the zombie, such as the player, will also generate messages while they are inside this sphere. However, as a zombie would not have a 360 field of view, any visual aggravators that are found out to be inside this sphere are first tested against the zombie's view cone. This is all done by the state machine, and we'll talk a little bit about that later on. As this trigger is going to be sensitive to anything that is considered an aggravant to the AI, I'm going to assign this to the AI trigger layer. We haven't got an AI trigger layer yet, so I'm going to go to the layer menu, I'm going to choose add layer, and in the next available free slot, I'm going to call this layer AI trigger, like so. Remember, this is different from the AI entity trigger, which is a trigger that is sensitive to the AI entity entering it. The AI trigger layer will be sensitive to any object which is considered hostile to the AI entity. I'm then going to select my sensor object in Jill's hierarchy, and from the layer menu, I'm going to assign it to the AI trigger layer, like so. Now it would of course be more realistic if we took our sensor game object here and actually made it a child of Jill's head bone in the bone hierarchy. As you can see at the moment, it lives outside of the root bone, which is our hips bone. Therefore, it isn't animated as the character animates. Therefore, if Jill was to suddenly go into a crawling animation, technically her eyes and her ears from an AI perspective would still be up in the air where the head was in an original standing state. The thing is, I did try this and it didn't actually work out that well. It caused some problems because for some of these animations, the head is doing some really crazy movements, looking up, looking down, looking left, looking right. When the zombie is feeding, its head is literally pushed right into the ground, and it just made the zombie seem a little bit dumb. You could be stood right in front of the zombie, but if it was looking to the left, even if it was in the middle of an attack sequence where the head turned to the left as part of the attack sequence, you would no longer register as a visual threat and it wouldn't see you. So what I do for now is I keep the sensor outside of the bone hierarchy, even though that's not technically accurate. Now I'll probably come back and address this in the future. I think probably the best thing to do that would give me kind of the best of both worlds would be if I write a script for my sensor such that it mounts itself to the position of the head bone, but isn't actually a child of it. You can imagine each frame that script might move the sensor so that it's always in the center of the head, but it keeps its own rotation and doesn't rotate wildly with the head during the animation. But for now we're going to leave it where it is because it certainly does a good enough job. So this is where things are going to get a little bit weird. You see, if I select the AI entity object in the hierarchy, we can see that this is the object that has Jill's animator, her rigid body, her capsule collider, and her nav mesh agent. Now, we've got settings on the nav mesh agent which are designed to stop the nav agent overstepping its target. We have, for example, the auto braking and the stopping distance properties. We saw when we were just dealing with just the raw navigation system that even if we had auto braking off and stopping distance to 0, that the nav agent would step past its target quite easily within a given time step. And you could get in a situation where the nav agent is just circling around its target, never being able to actually reach it. For example, if we just did a simple distance check, we might be 1.1 meters away from our target. We might say if we're in a 1 meter radius of our target, then we should stop and move on to, say, the next waypoint. But at 1.1, we wouldn't be close enough to our target to do that, so we would still think we have to move. However, as root motion is now dictating the speed of our nav agent, the next time root motion is applied, it could actually move our character, say, 3 meters, and we would suddenly find that when we do that distance check again, that we are now further away from the target than we were when we checked on the previous frame, because we've walked right through that target and now have walked away from it by a greater distance on the other side. Now, while there are obviously ways that we can fix this in code easy enough, I found that because I was eventually going to be using lots of different animation controllers with lots of different animations all delivering different root speeds and therefore different movements per frame, I decided that rather than do it in code, I would use Unity's trigger system to make my life a little bit easier. Plus, Unity's trigger system is lightning fast. So what I do instead is whenever there is a target that the zombie is heading towards, be that its next waypoint, be it the player if the zombie was in pursuit of the player, or be it some other stimuli that the zombie wants to investigate, such as a sound source or perhaps a dead body that it wants to feed on, it always, once it's been given a new target, sets a sphere trigger at that target's location. It then heads towards the target, and when it enters that trigger, the AI state machine is then notified and it knows it can then move on to the next target. So we're utilizing Unity's trigger system to tell us when the target has been reached. This makes it delightfully easy to set up and also very easy to adjust the stopping distance on a per zombie basis by merely adjusting the radius of the sphere trigger that's used to bound its target. So in order to do that, we could just create a sphere trigger, put it in the scene, and then assign it to one of the zombie's parameters. But then we would have lots and lots of sphere triggers all cluttering up our scene. We wouldn't know which one was intended for which zombie. Furthermore, as we want every zombie to have its own target trigger, we want that to become part of its prefab, so it needs to exist in a zombie local hierarchy. Therefore, what I do is something a little bit weird, but as long as you bear this in mind when you're playing your level and testing it, it shouldn't cause any problems. So the first thing I do is I create a container object for my zombie, which is going to contain the AI entity and the target trigger. So let's create that container game object first of all. I'm going to right click on my AI entity object and I'm going to choose create empty to create an empty child game object. I'm then going to call that Omni Zombie Jill. Now, calling it Zombie Jill is obvious, but you might not know why I've called this Omni Zombie Jill. That's going to be something I'm going to explain later, so for now just forget about it. So this Omni Zombie Jill game object is currently in the exact same position as the AI entity parent because it hasn't been offset at all via its transform. What I'm going to do now though is move it outside of the AI entity hierarchy, so it's now its own standalone object. Then I'm going to parent the AI entity object to the Omni Zombie Jill object, so it's now contained within it. Omni Zombie Jill is now a container. I'm then going to create a new game object of Omni Zombie Jill that's going to be used as our target trigger. So I'm going to right click on Omni Zombie Jill, choose Create Empty, and with the new child game object that's created, I'm going to rename this Target Trigger. In a moment, we'll add a sphere collider to this and set it up to be a trigger, but for now, just take note that the AI entity is the thing that moves and is managed by root motion and the nav agent. The target trigger will not move with the AI entity, and that's a good job. That's why I've done this to begin with. If I'd made the target trigger a child of the AI entity, then whenever the AI entity was moving towards the target trigger would be moving with it, and we would have a ridiculous carrot on a stick situation. So what we've done is we've said let's create a container object that contains both the trigger and the entity. The entity can move freely of the target trigger, therefore when we set the target trigger it isn't influenced when the AI entity is moving towards it. We can then, because they're all contained in the Omni Zombie Jill game object, prefab that as a single self-contained unit. Now the reason why I say it's a bit weird is you do have to bear this in mind when you're playing your level in the editor and you're looking in the scene view, because it's quite common to think, hey, where is Zombie Jill at the moment? Click on a top level game object and you would see that she wasn't appearing to be moving. Then when you clicked on Omni Zombie Jill in the scene view and zoomed in on her location, you just see an empty game object and the zombie mesh itself would be nowhere near its parent object. That's all by design. You just have to remember that when we're using this, when we place them in the scene and press play, from the moment the zombie starts animating, the AI entity will be wandering around freely of the Omni Zombie Jill parent object. Okay, so let's now go to our target trigger and let's set that to the AI entity trigger layer. Remember, this is the layer that is sensitive to the zombie's capsule collider entering it. That's exactly what we want. When we place this target trigger around the target location, we're going to be notified when the zombie's capsule collider enters this trigger. So you see now there's a classic example of the AI entity trigger layer. So with that object selected, I'm going to choose Add Component and I'm going to add a sphere collider. I'm going to set this to be a trigger, and for now I'll just set it to something like that. A radius of 1 point. I'll just set it to a radius of 1. What the hell? It doesn't matter. You're going to see later on that this radius is going to get overridden anyway by our AI state machine. Basically, our AI state machine is going to have its own stopping distance property that it's going to use to override and set the radius of this sphere. For now though, just understand what we've got. We've got a trigger that can be independently positioned of the zombie and will notify the zombie when its capsule collider, this thing here, enters the target trigger. That's when we know we've reached our destination. Then it's time to move on to the next target, and the AI state machine will reposition this target trigger at its new destination location. For now though, I will reset this so it's positioned at the zombie's position. So next we'll create a brand new animator controller that's going to be used to handle all of Jill's animation states. So I'm going to create this in my Dead Earth animator controllers folder. I'm going to right click, choose create, and I'm going to create a new animator controller, and I'm going to call this Omni Zombie 1. Now to explain that whole Omni Zombie thing. Well, you're going to see later on that we're going to create lots of different animation controllers that do all sorts of different things. Some of them will be very specialized to like guerrilla animations. The Omni controllers and the Omni zombies are simply zombies that can essentially exhibit all characteristics such as walking, running, crawling, reanimation, attacking, and things like that. There will be times down the road where we're going to create animation controllers that are very specialized and perhaps don't exhibit all of those behaviors, such as, for example, a zombie that starts the level in a crawling position. There would be no need for such an animation controller to have all the additional layers that are being blended to handle all of the animations that it's not even going to exhibit. So that's all OmniZombie means. It just basically means this is a controller that is a generic zombie controller that will exhibit all of the behaviors that a generic zombie can do. And the reason why I call it OmniZombie Jill in the hierarchy view is this is basically going to be a prefab of the zombie Jill that has been assigned to the OmniZombie controller. In other words, this is a great prefab to use when we want to put a zombie in the scene that looks like Jill that can do all of the generic zombie things. I'm now going to double click on OmniZombie 1. I'm going to open up the animation controller. I'm then going to put, for now, just a zombie idle animation in there as its only state. I'm going to do that by going to my animations folder, drilling down into my Mixamo animations folder, and I think I'm going to drag over zombie idle 1, this one here. This is going to be a kind of alert zombie, like so. So I'm going to drag that over, drop it into the animator, and you can see this has been set as the default state. This animator controller is currently not assigned to Jill, so let's do that now. Remember though that the animator doesn't exist on the parent OmniZombie Jill game object on the AI entity object that has the animator, the rigid body, the nav mesh agent, and so on. As you can see at the moment, it's still been assigned the animator controller root motion authority that we created in the last lesson. So let's replace that with our new animation controller. So I'm going to drag over OmniZombie 1 and assign it to the controller slot of OmniZombie Jill's animator. There you go. So now it's time to think about some of the parameters that we're going to need, at least those just to get us started. We're going to be adding to this parameter list as we flesh out our zombie controller, but for now we just need a few of the basics. So let me open this up a little bit so I've got a bit more room to work with. So the first parameter I'm going to add is going to be a simple one. It's going to be a float, and I'm going to call it speed. I'm then going to add another one, which is an integer, and I'm going to call this seeking. Now, seeking is essentially the turn on spot parameter that we had in the previous lesson, where 0 means it's not turning on the spot, -1 means it's turning on the spot left, and +1 means it's turning on the spot right. The next thing I'm going to add is a boolean called feeding. We know that when this boolean is set, that the zombie should remain in the feeding state. So I'm going to call this feeding, and it's of type boolean. I'm then going to add another boolean called crawling. This is going to be set when the zombie has either been damaged to such an extent that it can now only crawl, or in the case where a zombie starts off crawling. That's something that we can choose on a per zombie basis. Simple fact is, when this boolean is set, the animator should transition into the crawling animation. So let's call this crawling, like so. So the next parameter I want to add is one that's going to handle when the zombie is attacking the player, or some other creature that it considers hostile. I make that an integer and I call it attack. Now the reason I make this an integer and not simply a boolean, as we did in one of our earlier demos, is that this animation controller is going to have an attack layer, and that layer is going to have multiple attack animations so that we can have a nice variety and we don't see the zombie just using the same old attack animation every time it tries to attack. Therefore, when we wish to attack, what we'll do is our state machine will generate a random number between 1 and the number of animations available, and we'll set it in this attack parameter. When attack is non-zero, basically means the attack layer in this animator controller will transition to the relevant attack animation. But we're going to see all that being used later when we create our multiple layers. The next parameter that I'm going to add is going to be of type trigger, and I'm going to call this hit. Whenever the zombie gets hit by the player or some other hostile creature that is attacking it, the hit trigger is going to be set, which is going to cause a transition into the hit layer that's going to have the zombie either being pushed back, pushed to the left, pushed to the right, etc. However, because there are going to be multiple hit animations and the hit animation we choose is going to be based on what side of the body and what body part has been hit, we're also going to create an additional integer called hit type. So in the game, when the AI state machine recognizes that one of its body parts has been hit, it's going to set the hit trigger, which is going to cause a transition on the hit layer. However, the animation that will actually be transitioned to is going to be dependent on how the hit type is set. For example, if it was set to 1, that might mean a left shoulder hit. If it's set to 2, it might mean a right shoulder hit. If it's set to 3, it might mean a stomach hit. If it's hit to 4, it might mean a left head hit, and so on. And we're going to see all that being used later on. For now though, I think that's enough parameters to go on with, but we will be adding more as we flesh out our AI and animation system. So let's now set up our base layer, which is going to be our main locomotion layer. Now currently we just have a idle zombie animation in there, so let's just look at this a minute and check it out. As you can see, it's an animation of a very alert zombie. It's quite an aggressive idle. Therefore, when we create our other states in this animator controller, we need to have ones that match this. It would look rubbish, for example, if this was the idle animation and then we transitioned into this kind of Frankenstein walk animation. It just doesn't look right. It's like all of a sudden it started walking and the zombie's got less control over its limbs. So when we create an animator controller, we're really looking for animations that transition well into each other, and that animator controller then has a certain behavior, and we can create other animator controllers that exhibit this more Frankenstein-like behavior, certainly, but this one is going to be a more aggressive zombie. So what I'm going to do now is I'm going to right click in an empty area in the animator window, and from the create state submenu I'm going to choose from new blend tree. Then I'm going to select the blend tree state and I'm going to rename it locomotion. I'm then going to double click on my locomotion state to give me access to its underlying blend tree. As you can see, if I select the blend tree, the blend type is one dimensional. That's exactly what I want. What I'm going to store in here is 3 motion fields: a walk, a jog and a run. The parameter used for blending is speed, which is also exactly what I want. So what I'm going to do is I'm going to create 3 motion fields. In the first one I'll put my walking animation. In the second one I'll put my kind of jogging, slow run animation. And in the third one I'll put my full-blown sprint animation. So let's have a look at the walking animation that we wish to use. Now I'm going to use this one that I found in the Game Institute Locomotions folder inside the Animations folder, and I've called it Zombie Walk Childlike. As you can see, the zombie doesn't look particularly damaged, but you know, it is quite laid back. It's a zombie that isn't distracted by any external stimuli. So that would make a good walking animation. So I need to make sure that, of course, I open up the Zombie Walk Childlike FBX file and I drag over the actual animation clip contained, which in this case is called 14201. Now the easiest way to do that is to select the blend tree and then lock the inspector. Then I'm going to go back to my locomotions folder and I'm going to drag over that animation clip 14201 into the first motion field. Now I want to find a more aggressive jogging behavior, and I can find that in the Mixamo animations folder. There's an animation there called Zombie Run. If I unlock the inspector for a moment, we can preview it. There it is. I think that's a pretty good sort of generic zombie patrolling quickly from waypoint to waypoint, so we're going to use that one. So once again, I'm going to select the blend tree and I'm going to go back to my Mixamo animations folder and I'm going to drag over the Zombie Run animation clip into the second motion field. For the third motion field, I'm going to lock the inspector again and I'm going to use that sprint animation that we used in our other demos in previous lessons, which is in the Unity Technologies folder, and it's called Default Avatar at Run Forward Neutral Face Forward. There you go. Now, if I select the blend tree, press play, you can see we have a walk, and if I move up the speed parameter, we then go into more of a sort of seeking run, and that goes into a full-blown sprint. In previous lessons, what we used to do is untick automate thresholds, and we would compute the thresholds based on something like speed, for example, and that would set the thresholds accordingly to correctly represent the actual speed of the animations. Therefore, if we wished our zombie to do a full weighted zombie run animation, we would have to set the speed parameter of the animator controller to 2.83954. Now, the problem is with this is that we're going to have lots of zombies and we're going to have lots of animator controllers, and they're all going to have different animations in their locomotion blend trees. Therefore, it would be very painful for me to have to know on a per zombie basis exactly which speed I need to set to achieve a zombie run, or which speed I need to set to achieve a zombie walk. So what I do is I do something quite different and use my own speed system. I use a system where in my AI state machine, if the zombie wants to walk, I give it a speed of 1. If it wants to jog, I give it a speed of 2, and if it wants to sprint, I give it a speed of 3. Remember, the root motion is still going to be generated in exactly the same way, but it just gives me a uniform way to tell any zombie, irrespective of its blend tree and the animations in that blend tree, what animation I wish it to use. So for our walking animation, I'll set the threshold to 1. For our jogging animation, I'll set the threshold to 2. And for our sprinting animation, I'll set the threshold to 3, like so. We now have speeds in the range of 1 to 3 that we can set that will invoke these animations and blend between them accordingly. This means that even if I have a zombie with a completely different animator controller that has completely different speeds and animations for its walk, jog and run, I will still activate them when I want them by just setting the correct speed in the 1 to 3 range. And I'm going to be using this for all of my zombies, okay? So there will be a uniform speed system across all of my animator controllers. So going back, we probably want to add some transitions. So I'm going to make a transition to locomotion from idle and back to idle from locomotion. And we want to transition into our locomotion. First of all, ticking has exit time off, and we want the condition to be if speed is greater than, let's say, 0.5. Doesn't really matter. As soon as a zombie begins to walk, its speed is going to be set to a minimum of 1, so this is going to be triggered. And of course, we want to set it back so that it transitions back into locomotion when the speed falls below 1. So I'll just say when it's less than 0.5. So I'm going to untick again, has exit time, add that condition, and say when speed is less than 0.5. Because when we actually want to come to a stop, we'll set the speed to 0. Okay, so now we need to add our turn on the spot animations, and once again we wish to find turn on the spot animations that match the behavior of our character, especially its idle. So what I'm going to do is I'm going to go into the Mixamo animations folder again, and there is the zombie turn FBX file down here where we made a turn left and a turn right, like so. I think these are the ones we're going to use. So I think we'll drag those in, turn left, turn right, like so. And then we want to make some transitions between these. Now remember, we have this seeking parameter, which is our turn on the spot parameter. So let me move these out a little bit and give myself a little bit more screen space to play with. So what I want is a transition from idle to turn left, from turn left back to idle, from idle to turn right, from turn right back to idle. And then what I also want is I want to be able to turn right if I'm already turning left, and vice versa. So I'm going to make transitions between my left and my right turning animations as well. Now I'm not too worried about going from locomotion into turn left or turn right, because one of the first things we do when it's time to turn is we first of all stop our speed, which will drop us back to idle. So I think that will probably be okay, but if not, I can always make transitions into turn left and turn right from locomotion if the need arises. So let's set up some of these transitions. Well, we're going to go from idle into turn left. First of all, unticking has exit time, and the condition being if seeking equals -1. And we're going to go back into idle from turn left, once again remembering to turn off has exit time, if seeking equals 0. Then I'm going to transition from idle to turn right, if remembering to turn off has exit time, if seeking is equal to 1, and back again to idle, if seeking equals 0. And then we need to hook up the transitions between zombie left and zombie right. So if we're in zombie right, we transition to zombie left, turning off has exit time, if seeking equals -1. And we transition from zombie left to zombie right. Oops, I've done that the wrong way around, sorry. So we transition from zombie left to zombie right if seeking equals 1. And we transition from zombie right to zombie left if seeking equals -1. So I think that covers all bases. Let me just check I've set them up right. Yep, looks good to me. Okay, so as this is our locomotion layer, crawling is also a form of locomotion. the fact that the zombie isn't walking because its legs are damaged doesn't mean that it isn't moving, it just means that it's crawling on all fours, but it's just a locomotion animation, so we're going to put it on the base layer, which is our locomotion layer. Now I've actually got two crawling animations, if I remember rightly, so if I go into my Game Institute locomotion folder, I think we've got crawl, there you go, zombie crawl 1, which is like a slow crawl, and zombie crawl fast, which is a faster crawl. So I think I'll put these in a blend tree as well. So I'm going to right click in an empty area, create state from new blend tree, and I'm going to call this crawling locomotion, like so. And then I'm going to double click into that to get access to the blend tree. And once again, we want a one-dimensional blend tree. We wish it to also be based on parameter speed, but as I only have two crawling animations, I'm going to add only two motion fields. Now I'm going to lock the inspector so that when I click on my animations, I don't lose the inspector for the blend tree. And where did I say it was? It was in my locomotion folder in Game Institute. And in motion field 1, I'm going to drag over zombie crawl 1 and zombie crawl fast. Oops. Zombie crawl fast, like so. Once again, I'm going to untick automate thresholds, and what I'm going to do is set these myself. So the first threshold is going to be what is equivalent to a walking threshold. So I'm going to set that to 1. Then I'm going to set the crawl fast threshold to 2. Now it doesn't matter that we don't have a third motion field here. If speed is greater than 2, for example, if we set it to 3, then it just means it'll be clamped at 2, and 2 is the animation that will play. So what we have now is the ability, using the same speed parameter, to say, hey, we want you to speed up your crawling and come at me much faster, like so. So the nice thing about our custom speed system, using speeds of like 1, 2 and 3, is we no longer care whether the zombie is crawling or whether the zombie is walking or running upright. All we need to say to the animator controller is, you've seen something that really bothers you, I want your speed to be 3. And in the case of a crawling zombie, that means it will clamp out at 2 and play the fastest crawling animation we've got. But it means that when we're not in the crawling state and we're instead in the standard locomotion state, it means it's going to be playing our, oops, let me unlock the inspector. It means we're going to be playing our full-blown sprint animation, like so. So pretty cool stuff, and we no longer have to care about what the actual speed of our animation clips are. So let's now create the transitions from Zombie Idle into the crawling locomotion. So transitions to and from, and I'm going to turn off has exit time, and the condition is simply going to be if crawling is equal to true, and we go back into idle if crawling is equal to false. Incidentally, this will never happen. Once a zombie in Dead Earth is crawling, it means its legs are damaged and it never repairs to the point that it gets back up from a crawling zombie. But let's just put it in there in case we change our minds about that in the future. But I don't think we will, because we don't really have an animation that will take us from a crawl up into an idle. Now you're probably thinking at the moment it's a little bit weird because we also don't have an animation that's going to take us from an idle down into a crawling, and it's going to look really weird if you watch the animation window here. That's not actually going to happen. You see, on another layer we're going to have what's called a cinematic layer, which is going to take over when the zombie is recovering from a ragdoll. So if you imagine the zombie has been shot, it's ragdolled, and it's fallen down onto its stomach. Now while this cinematic layer has focus, we're not going to see this transition from idle to crawling locomotion because it's being overridden by the cinematic layer. And that cinematic layer will essentially see the zombie be a ragdoll for a bit, and when this layer, the base layer, once again gets its full weight back, the zombie's already going to be in a crawling animation. So it's going to look fine, but you'll have to take my word for it for now. You'll see it later. Okay, so I think the only other thing I have to do, which once again is just really a paranoia check because I don't think this can ever happen, but I'll just make sure, is the transition from idle to turn left and turn right should also never happen if the zombie is ever a crawling zombie. Now this isn't actually ever going to be happening, but I'm just going to say that never transition into a turn on the spot animation if the zombie is crawling, okay? Just to cover all bases here. It would look really weird if the zombie crawled up to a waypoint, then when it got to the waypoint it just magically got up on its feet and went into that kind of seeking turn on spot animation. So we only go into those if turn on spot is false. So we've got quite a bit of the menial prep work done for now, but the next step is going to be to start writing our AI state machine behavior and our various AI state behaviors that are going to be managed by the state machine. Now this is going to be a pretty big topic. It's going to cover several lessons. It's going to involve writing a fair bit of code. Furthermore, it's going to need a little bit of theoretical discussion first. So I want to start that process at the beginning of a video so that I can get some way into it before I have to break. And I know we haven't had a chance to really test any of this yet, but we can't begin to test this stuff until we have the AI state machine script, which is kind of the manager that talks to the animator and talks to our triggers. So I'm going to leave it there for this lesson. I will see you in the next video. Thanks for listening, guys. Bye bye.